Okay, now we are going to continue here with the 710 lecture. You remember we left off. This should look familiar to you with when we talked about Q before. And what we're going to do at this time is just move ahead and do some problems that have to do with calculation of these KSP values or QSP at a given moment in time. All right, so let's go ahead and take a look, see what we got here for our next problem. You can see that this is quite involved. And the first thing it says is find KSP for a saturated solution. And all you're given is the concentration of the Cl minus. All right, so just the chloride ion when you are looking at the saturation. So they did some sort of test, reacted it with something else to find out the concentration of the chloride ion, and then you could calculate from there. Well, of course, the equation, and you got to get really used to these, solid going into its aqueous ions. Writing the KSP is going to be required for you here, and then plugging in the S and 2S as we did in the previous example. The thing about this one is we don't know the KSP, but we do know the chloride ion concentration, and this is the little curveball they like to throw at you. You know, if you give you this one, you just double it. But you got to recognize that you got to cut this one in half in order for these to be at the equilibrium concentration. So that's just working that problem in reverse. KSP value turns out this, of course, is not a significant figure. It's a half. That's a mathematical function. So you got 3, 3, 3 there. No units. And hopefully you crunched those numbers without a problem. So kind of working the problem in reverse to get that KSP value. And now step 1, find the concentration of Cl minus. Okay, so what they gave you initially is the concentration is found to be 0.325 molar. Now, once we sort of add this new thing to the mix, it says, will a precipitate of lead chloride form when you add these two solutions? Okay, so you got a new volume to account for. We don't just have the one ion in 1 liter, so you got to do some crunching here. We have 200 milliliters of the one and 3.78 moles per liter, so you have to recalculate and get the number of moles of ions in that solution, which would be, just basically a fifth of what the moles would be in the concentration. All right, so now you take the moles and then you got to put that over your whole volume. This is really the gist of getting these problems. The whole volume is you added 200 milliliters plus 100 milliliters, so of course it's going to be 300 mils or 0.3000 on the bottom there. And the number of moles of chloride you just figured out. So that is your concentration. Once you mix those two together, and you have a smaller volume than say 1 liter. So now to figure out the lead, very similar. You've got just 100 liters. That'll tell you how many moles you got to work with. Now put that over the total volume, which of course is the same because you added 100 milliliters of the lead ion, and that ends up giving you your concentration of the lead plus 2 ions. All right, so that's step 2. Now step 3, find the Q for lead 2 chloride solution. Q equals the concentration of the lead times the concentration of the chloride squared from that initial equation. And we just figured out these numbers. So we just got the 8.17 and the 0.0252. So that's where you plug those numbers in. And of course you have to square the chloride. And that allows you to get the concentration of Q in this problem. Again, no units. Watch your sig figs. Now the key to really getting where you're at, if you added those two solutions, would a precipitate form? Well, as it turns out, our Q, once we figured out these new concentrations, is less than the KSP. Therefore, no precipitate will form, and you have a clear liquid that you add drops of to another clear liquid, and it stays a clear liquid. You could prove this experimentally by taking those concentrations of solution. No precipitate will form because your equilibrium initially is below the KSP value. All right. So what will happen is then we're going to talk about this common ion effect, and that is actually going to be saved for the day 2 of this. All right, so we finished lecture 2 right now, and we'll start with this common ion effect. Very important concept, and kind of a nifty little next level on Le Chatelier and the equilibrium constant, and how that can change an equilibrium system. So we'll put that one on hold until next class, depending on when your lab is, and we'll talk about the common ion effect and give you enough skill to finish the whole problem set. But for right now, again, do roughly the first half of the problems. And if you could do one like we just finished, that's really good practice for you, to see if you could recreate this last problem, where you got the total volumes down here on the bottom. If you could do one of those on your own, yeah, you're in the big leagues. All right, so enjoy. This is the relaxing part because it's not due, but don't put it off too long. You don't want to be. I'm still seeing some of those 2:35 a.m. submissions. You don't have to put yourself in that position. So get some problems done. Get a good start on this. Bye.